Hello everyone. Today we're going to learn about inequalities. Just like equations, except instead of getting a single answer, we get a range of answers. So let's look at some simple inequalities. Here. This means y is greater than x. That's our greater than symbol. So, when we find an answer for this, we want x, y values where y is greater than x. For example, 1, 2. X is 1, y is 2, y is greater than x. If we were to graph the answer, we could draw a line of x is equal to y. That's our x is equal to y line on the xy plane. And for every point on the left of the line, this entire region here, our inequality would be satisfied. The y values would be greater than the x values. We'll do some more practice with that in a bit. Let's look at our equation here, our inequality here. This means x is greater than or equal to 3. Greater than or equal to. So, if we were to graph this one, and x is equal to 3 is here, our answer would be the entire region to the right of this line, because all the x values to the right are greater than 3. And we include the line, here we include the line x is equal to 3 as well, because our symbol is greater than or equal to. Now, let's look at our third inequality. Y is less than or equal to 5. If we were to graph this, where this is our point 0, 5, where y is equal to 5, our answer would be the entire region below this line, because our y value is less than or equal to 5 for all points below this line. The entire region I've shaded there. This is our y-axis. And for our fourth inequality, here we have to do a little simplification. The good thing about inequalities is you can add or subtract from both sides without changing the symbol. The symbol will hold. So if y plus 1 is less than 4, y is less than 3. And we can graph that. Y is less than 3. If this is our point 0, 3, we want everything below that line, not including the line itself, because it's less than. Everything below the line. Okay, let's try some operations with inequalities. We already learned we can add or subtract from both sides without changing the sign of the inequality. We can also multiply and divide. And for positive numbers, we don't have to worry. But for negative numbers, we have to switch the sign of the inequality if we multiply or divide by a negative number. Let's look at this example. 3x is less than 7. So, we divide by 3 on both sides, and we have that x must be less than 7 over 3. Since we divided by a positive number, our sign has stayed the same. If we were to graph this, and this was our point 7 over 3, 0, then this entire region to the left would satisfy our answer. All points here have an x value less than 7 over 3. I'm going to use a dashed line to indicate that the region doesn't include the line x is equal to 7 over 3. You might use a different notation in your class, but this is what I'm using, dashed line. And I'll use a solid line to indicate less than or equal to or greater than or equal to. Now, let's look at an example for a negative number. Here, if we want to separate x by itself on one side, we have to divide by -3. So we get x is greater than -2. Since we divide by a negative, the sign flips. Our less than becomes a greater than. If we graph this now, x is greater than -2. We get this region to the right of this line. This is the region where all x values are greater than -2. And let's look at how this works. We can take any point in this region, say 1, 1, that would be around here, and we plug it back into our inequality to see that it works. If x is equal to 1, then -3 times 1 should be less than 6. -3 is less than 6, that's true. So this answer is correct. And what would have happened if we didn't switch the sign? If we didn't switch, we would have gotten x is less than -2. So a possible answer could have been x is equal to -4. And if we plug that in to our original inequality, we would get 12 is less than 6, which is clearly wrong. So remember, a good way to check if you've done things correctly is to choose a point in the region of your answer, plug it back into the inequality, and check if you get the right answer. Alright, next we'll try some practice problems.